In the name of God, my name is Hadi from Iran. This research is about using reinforcement learning in dynamic pricing problem by considering customer behavior and advertising. About the problem outline, we have a multi-arm bandit problem. As you can see, the population is present at the first of each period, and after some interaction into the system, the customer can decide to buy, leave the system, or stay in the system for the next period. This will be repeat from t equal to 1 until t equal to n. If I want to speak about the system, first of all, the seller proposed the PI in respect to unknown initial distribution, and by aiming to maximize his revenue. After that, the customer observed the price, and based on the expected value of the product, and by comparing to current price and the expected price, and based on the some terms that we call patient of the customer, and we shall with the delta decide to buy, leave the system, or stay in the system. And after that, the seller observed the buyer's decision and update his belief, and consequently update the price of the product by aiming to maximize his income. We have some assumption. Some most important is the inventory is unlimited. The customer are divided into myopic and forward-looking. The myopic and forward-looking customer have a same willingness to pay. Expect that the forward-looking customer can postpone his purchase, and the population is present at the beginning of each period. We have some variables. The PI is the seller price on the arm of the eye. Delta is the customer patient, which is the terms that divide the customers into myopic and forward-looking, and it is between 0 to 1. We have a demand for myopic and forward-looking customer. About the equation, first of all, the customer decide based on this equation. In this equation, mu I is a willingness to pay, A is advertising, which is decreased during the time, delta is a customer patient, and P estimate is the prediction of the price. We can calculate the probability of the purchase based on this equation. And if I want to have a two boundary terms, you can see when the delta is 0, which means the customer is fully myopic, the demand of forward-looking customer is equal to demand of the myopic one, and if the delta is equal to 1, which means the customer is fully forward-looking, we can calculate the demand on the some condition. We developed Thomson sampling model based on the Bernoulli and normal demand. In the Bernoulli demand, we obtained the sample theta I from the distribution of beta, and after that we choose II by aiming Argmax distance, and finally we choose a Bernoulli sample by success probability of R, and if the result is equal to 1, we add to reward. On the other hand, we add to the F. In the same way, we develop this algorithm for the normal distribution. You can see the steps. It's like the Bernoulli distribution. In the numerical result, first of all, we can see that by increasing the delta, which means by going from the myopic customer to forward-looking customer, the sellers have to propose less price, and you can see the same pattern in the normal distribution and normal demand. About the income, you can see if we use the developed Thomson sampling in the presence of the strategic customer, we earn more. This is for the Bernoulli demand, and you can see and the same for the normal demand, but in the normal demand the difference is less than the Bernoulli demand. We propose some suggestions. If we face with a myopic customer, we should identify the exact value of the or willingness to pay of the product for the customer, and price based on it. But when we look the forward looking customer, we can use dynamic pricing and change the price during the period by aiming to maximize our revenue. Thank you. If you have any question, you can find me at hardy.mohammadi@outlook.com.